All right, and we are live, coming back with a kind of a mini form of the Ops show and looking more at the technical side of everything involved with DevOps. And I have with me today Ben Slater from CTO.ai, the Director of Technology here. We just recently did a little bit of a video called Celebrities Explaining DevOps, where we had David Hasselhoff, Flavor Flav, and Carol Baskin explain varying technologies within DevOps, Docker, AWS, and Kubernetes. And through that, we had a huge influx of people join the ops community, that our community that's focused on workflow automation, DevOps, and the CTO.ai platform that helps people, becomes the control plane for your technology within the developer and operations infrastructure. And we had a lot of questions in the community around, how does DevOps work exactly? How do I use Kubernetes? How do I get that DevOps 101 knowledge so that I can really get started, upskill myself, and help my team become more efficient and productive? And so we wanted to do a little bit of an intro to DevOps session here, first of its kind, and hopefully not the last. And Ben here, our Director of Technology, knows it really well, goes through this with a lot of our clients, and he's got a little bit of a presentation, and then we'll open it up to as an AMA. So if you have any questions about DevOps and you need support in any way, Ben's here to help. We'll also have some members of the CTO.ai team in the chat. So we'll be answering questions twofold. So feel free to chime in with your questions at any point in time. And let's kick it off. I'll hand it over to you, Ben, to kind of give us that presentation, and then we'll go into AMA.
Okay, thanks, Tristan. You can hear me okay?
You sound great.
Thank you.
Pulling up your presentation and closing myself down.
Okay, yeah, thanks, Tristan. Yeah, so as Tristan said, this is a new series for us that we want to try doing. We're dubbing this as an introduction to DevOps, and so we'll be covering many technologies and how we can interface with it, as well as giving you some insights in terms of how you can tap into this technology using the Ops platform. So in today's session, we're going to go over Kubernetes. A lot of the advantages that the Ops platform brings you is that it's able to abstract away a lot of the setup process of trying to integrate with the technology, as well as some of the maintain steps. But without having a good understanding in terms of like what the technology is bringing to you, you're sure to get stuck and have a little bit of trouble in the future. So again, that's why we want to try to launch this series. And so today we're talking about Kubernetes, and I want to present to you guys a general overview in terms of like what the technology is. I want to get into a little bit about like what you can expect from the technology, how you interface with it, and mostly getting out into why you'd want to consider using it versus other tools in the DevOps library. Okay, so what is Kubernetes? So Kubernetes is a portable, extensible, open source platform for managing containerized workflows and services that facilitates both declarative configuration and automation. It's quite a mouthful. But the main piece that I want to try to get across to everybody that's watching is that Kubernetes is helping you with container orchestration. So it allows your containers to be able to talk to one another. And so from a developer's point of view, you are interacting with a single point interface. Usually it's kubectl. That's a command line tool that allows you to talk to the Kubernetes cluster. So the way that the Kubernetes cluster is set up is that you have a series of nodes. Nodes are the machines that the containers are running on. So in this just simple example that I've kind of got as a diagram here, we have 3 nodes in our cluster, a node A, node B, node C, that could be in multiple regions, to help you provide better availability for your services. And then on those nodes, the pods are actually your containers. And so you might have pods for your API, maybe your website files, like your React stuff, for example. And Kubernetes is in charge of deploying those containers onto the nodes itself. So it's not as much of like a manual intervention or a manual process of the developers trying to worry about that stuff. Kubernetes is handling all of that, and the interface that you're working with is telling it to provision the space for that stuff. In addition to kubectl, another really useful tool in your toolkit is the Kubernetes dashboard. You can do, I think the command is kubectl proxy, which allows you to proxy to the Kubernetes dashboard. And this is just like an interface for you to actually see. It's kind of your command center. You get to see the state of your Kubernetes cluster. So it'll show you how many deployments you have up, as well as the number of pods. And so you have your replication sets, which is, so maybe you want to say you have 3 copies of your API, maybe you have 2 copies of your React website. All of that information will be shown on the Kubernetes dashboard, but you can also access some of your stuff like your deployment instructions, like how you want these pods to be rolled out. But you can also have like secrets information and stuff like that for how the secrets are mapped into the containers. So to be able to add or update like deployments in your cluster, you write a configuration file. It's a YAML. And so in this example, I was showing an express.yaml. So maybe you have an Express app. This file will provide you information in terms of the deployment state. So it'll say what are the number of replication sets, what are the values, like your environmental variables or secrets that are going to be read and used by the container. It also allows you to specify the resource needs. So you can say what is the minimum amount of CPU that this container is going to need, or what's the minimum, maximum amount of memory that you want to be able to use for it. And then Kubernetes will make sure that there's space allocated within the nodes that would be able to launch the number of replicas for the pods that you wanted. So in this particular example, so I'm treating it like a new deployment of express.yaml. And so Kubernetes will handle deploying copies of that across the nodes. In this case, we had some space in our node C, and so it probably would open up some pods there for your Express YAML. But again, the advantage here is that Kubernetes is handling where your resources are being provisioned and not so much focused on you having to decide exactly what machines everything's on. Working with secrets is very similar. And so you, one big point that I wanted to raise too with kubectl, the command is kubectl apply -f, and then you specify the YAML file, and then it will deploy it to the Kubernetes cluster that's being configured to be connected with kubectl. So yeah, so this is the same thing. You can deploy your secrets. Secrets are handled in a separate spot on the Kubernetes dashboard, which is really clear. You could have all of your secrets in a single file if you wanted, or you could do something a little more organized and have secrets split across your services. So an example of what we've done in the past is we've had multiple services that'll connect into a singular database. Maybe one service is writing to a database and another service is responsible for just reading from it to surface that information to your web app. You can have the secrets that are associated to the database connections in a particular, maybe a Postgres secrets file. And so all of your deployment configurations can reference that specific secrets map. So another big advantage that Kubernetes provides you is it allows you to auto-scale. And so when users are accessing your web app, the Kubernetes API, it's communicating with the nodes and the pods that are receiving traffic. And so if there's a higher usage and maybe more people are visiting your React website, Kubernetes can deploy additional replicas depending on what your min-max levels you set for the number of pods that you want to be able to run. And then in time, as the number of users starts to spin down a little bit, it'll go back to the original state where you have like less pods. So you're not paying as much money to try to have as much availability at all times. You can kind of scale with the ebbs and flows of the network. And so what users see, so here I was just using an example of like a website like dailyhot.com. Users communicate will be on that website, and that website is making API calls to Kubernetes. Kubernetes is then going out to all of the pods, and these pods can be deployed across the node instances to be able to pull in the proper amount of resources to properly display the web page to those users. And so they don't see anything different, but this allows you to have containers working in tandem across all of your compute instances instead of having it all like duplicates. So I wanted to go into something real quick. This is what I'm deeming. I'm using this terminology. I don't know if it's accepted in the field of DevOps, but I'm calling it classic DevOps. And this is kind of what developers used to do. And so when users are, visiting a website, so again, dailyhive.com, they are being trafficked through a load balancer to be able to land on an EC2 instance that has a copy of the React website as well as an API to respond to that. In this example, or what people used to do, you'd have multiple copies of an EC2 instance that are exact copies of one another, such that, depending on the number of users that are coming into a website, they're just being directed to one of those copies to try to reduce the overall load on the network. So what that means from a developer's perspective, if you want to try to deploy some new changes, you'd have to go through the AWS console to spin up some new resources. So you'd create a new EC2 instance, and then you'd either SSH into it. There's multiple ways to connect to that EC2 instance. You could also do stuff like SCP to secure a copy, or you could do FTP or Heroku, something like that. But basically, you're trying to get your code, the latest state of your code on that machine. You'd run some manual tests here just to make sure that everything is running and working okay, that it's not just dying, staying live. Then you'd have to update your network load balancer to now start pointing traffic into this new EC2 instance, just so you start testing real traffic and starting to see what this flow looks like. And then after some testing, making sure that this works, you have to then shut down all the other EC2 instances and spin up a new copy each time to be able to replace it, such that you've now effectively rolled out a new deployment and you're now working with this new copy, or this new state of this website. So some problems with classic DevOps is that this is a very error-prone process, because it's like manual intervention is done across all of those steps. And so, if anything goes wrong, then, you have to, manually correct it, or, change the resources and stuff, or remember to switch things back to a previous state. And in a worst case, if the failure is not caught before rolling out all of the new EC2 instances, it's a pain in the ass to kind of have to roll back and go back to the original states. Because again, if you're working directly with the underlying machines and the copies of the code and how that is all working. The example is a little bit more extreme when you're doing working with Git repositories, and you're not actually working with containers. A lot of people have already accepted, containers are the way. Containers are more, you can replicate the functionality a little bit better, and you get less of that works on my machine mentality. But the problem with using this classic DevOps, which is still true using containers, we have containers running in each of your EC2 instances, is that the containers across EC2 instances are still not able to communicate with one another unless you put in something like a container orchestration technology, like Kubernetes in this example, which seems to be like the best right now, or doing something like Docker Swarm. Okay, that's all the slides that I had, but that's like the general overview of Kubernetes. And so the main reasons that you'd want to use something like Kubernetes is it allows you to be able to, as a developer, interface with a single point to try to roll out your resources into your, for your application. You get better scalability at a lower cost, and it's less just manual interfacing with things. The amount of stuff that we can start automating, the more that we can automate, the better. Okay, thank you.
All right. Thank you so much, Ben. Really appreciate the time. And now we'll turn to the stream here with some questions. Uh, the first is Don, our famous DevOps hero, Don Burks, asks, what's your ideal DevOps stack to accompany K8s, Prometheus, Istio, Grafana? Basically, what's that suite of tools that lets you feel that you're properly orchestrated?
Yeah, no, that's a great question. Yeah, so those are definitely like great examples. Those all perform for each one of those tools listed has a completely separate task. So one of the main tools that we always roll out with our clusters is Prometheus and Grafana. Prometheus is an APM, so it's able to send in like state information as your applications are running. And then Grafana is where you're able to create dashboard visualizations. The advantage of using something like Grafana is a lot of the dashboards already exist. And so out of the box, there's a Kubernetes dashboard that just by using Kubernetes, all of the nodes and deployments and replica sets are already sending standardized metrics that they will immediately be picked up on your dashboards to be able to see, like, what's the CPU usage, how many pods are operating, at full capacity, what's the scalability look like, and what are the times of the day when, traffic is scaling up or scaling down. So you can kind of control that a little bit more. Istio is a little bit more complicated because Istio is related more to sidecar technologies. That's where it's like you want to try to do stuff like blue-green deployments, like rolling deployments, but you can also test out different states of pods and stuff. You could do some of this stuff in Kubernetes following like namespaces, but I think that's more of an advanced topic that maybe we want to revisit a little bit in the future. But I would definitely say Prometheus, Grafana are really good pieces that you want to do. And Kubernetes is just another tool in the DevOps toolbox. It's kind of like managing the orchestration. So you want to include stuff like observability, but you also still need to consider other pieces of your stack, like Kong, for example, like your API gateway, instead of using some of the lower level tools like an ingress egress, which are the networking pieces, how the pods talk to one another and how the outside world talks to the pods. So yeah, that's kind of how I would answer that question.
That's great. Yeah, it's obviously there are so many different services and microservices within the greater, DevOps cloud architecture industry and space that it's like you can't be an expert in everything. So I think a lot of times we try to take that approach of lean DevOps and trying to stay as simplify as much as possible. And let's see, the next question here is Danny from the community. What are the best resources to learn DevOps? Any books you could recommend?
Yeah, that's a great question. One of the biggest points that people need to understand is that DevOps is less of a person and more of a culture. And so you'll see a lot of diagrams and stuff of it being like the like almost the infinite loop type of a circle where it's going through the planning, implementing, measuring, because you want to see the observability and the feedback as you're cycling back to fix on some of those bugs and stuff like that. A really good book that kind of gets into why you would care about DevOps and why you'd want to use it is Accelerate, which probably everybody that's in DevOps has been recommended that book or has tried it. The author of that book, or one of the authors, Nicole, I think she was also one of the main people that wrote the DevOps like handbook and started actually creating the culture around DevOps and what it stands for. But those would be two great books to pick up.
Yeah, that's great. And I see also like DevOps for Dummies. Emily Freeman was just a guest on the Ops show recently, nice. And she premiered today her episode on YouTube, and that's another great kind of like intro to DevOps book. And I also see Ian out there says the DevOps handbook as well.
Mm-hmm. That's a great one.
Yeah, awesome. Let's see. So the next question is Ryan from Ryan in the community. Is there a cool resource where we can see how all these DevOps tools out there tie together?
Hmm. I mean, that's a great question. I mean, CNCF is a good resource, I would say, just because that starts to show out all of the, I guess, the tiling of all of the individual technologies. Because a lot of the technologies, like Kong, for example, are larger pieces that try to do more of a role of working with some of the underlying technologies. The underlying technologies get really deep, and there's like hundreds of integrations. But CNCF, their main website, actually shows you all of the boxes in terms of how all the pieces are connected up. So it shows you all of your networking based tech, um, which pieces are using, like allowing you to provision stuff, or what pieces are using more for the observability sides of it, tracing. Yeah, actually going back to the previous question too, like as you start getting into Kubernetes and you start having more of a microservice type of applications, being able to trace, trace where the calls are being made across the entire stack is going to be really helpful. So I would also recommend checking out Jagger. It's a Golang based tool, but it's really deeply integrated into CNCF and like that whole side as well.
That's great. Yeah, I know personally, it's helpful yet a little scary. The link I just posted around the landscape of CNCF and
Yeah,
how many tools and different technology options there are out there. Uh, I think
yeah,
that I think like kind of like you were saying, it's like it's beyond like a DevOps isn't a person, it's a culture, and like
mm,
this kind of culture part comes first. And so some of the I think it's a good question about some of the things you can read to like learn more about how that culture exists. And I think
yeah,
another good blog post I'll put in there is kind of our idea, and Kyle, our founders, said this a lot. It's like the lean DevOps, this culture of delivery, and how do you think about having this leaner culture that is, helps people increase their velocity and observability in the process, so that you really know what's going on with your DevOps process.
yeah. I was going to say too, I'm not endorsed by Amazon, but AWS is an awesome resource. Some of the documentation, it's definitely written by very technical people, so it can be kind of hard to get into. Um, but there's numerous blogs and just docs in terms of how to interface with a lot of the AWS stack. But a lot of what they're trying to do, and they've been stepping up their game a lot, is trying to make you know managing Kubernetes clusters much simpler, as well as working with other containerized tech or Lambda or Fargate and stuff like that. So yeah.
All right. Well, I see one more question over here, and I just found out that I can do this show at the bottom here, so that's kind of cool. Although it cuts it off.
Oh well.
Um, Kyle asks, "What's the first three things someone should learn if they want to have a solid foundation for how to approach DevOps on the job?"
That's a great question. I mean, just listing tech, you definitely want to be experienced with AWS, understanding kind of the not the bare bones level, but understanding how all the pieces are kind of connected up. I would say that I don't I don't know if it might be too obvious of an answer, but just understanding containerization, like Docker Compose, how you're able to make your containers talk to one another, like within networks, helps a lot too. Um, I'm trying to think of an example that Steve provided to me. So like he's one of our senior developers, but he was describing, because I'm trying to think of the image format for the Docker images. I can't remember off the top of my head, but because everybody always references or quotes Docker in terms of I have Docker containers or I have this Docker image. It's like it's it's kind of like a PDF. Like you don't need Adobe to be able to read the PDF. There's tons of technologies and stuff that will read PDF documents. Docker's just one of, it's kind of the Adobe in this example. It's just what's able to read the particular image file. Um, there are numerous technologies that are able to interface with it. It's just Docker kind of made it the most approachable. So it's actually just a really good one to know. Um, yeah, I would say, yeah, solid foundations. You really need to understand observability and the concepts of that. So, like, how do you know how your cluster, or not even just your cluster, how do you know how your infrastructure is doing? So it's like, do you know whether when something goes down, what does your alerting look like on that side of it? Understanding, getting back to automations as well. Thinking about like infrastructure as code is another big piece too, because a lot of classic older DevOps is kind of like going through and running bash scripts to kind of set up an interface directly with the AWS components, like being able to create the EC2 instances or set up your VPCs or set up your networking properly. Amazon has a lot of really cool tools like CloudFormation, for example, to allow you to be able to set up repeatable infrastructure so that you'd be able to spin up infrastructure in a very consistent manner. But there's a lot of tools, technologies around there too. Like you could use Chef or Puppet, Ansible, Terraform to be able to spin your resources. But the main concept there is trying to focus more on repeatability. If you're able to, spin up and spin down your technology or your infrastructure repeatably, then you're in a really good spot.
Yeah, that's great. And how does like, the ops platform by CTO.ai plug into this whole thing? Like, can I use this to manage all of my services? Like maybe as a last question, give us a little bit of a 1,000-foot view on how someone could take that and run with it.
Yeah, and so kind of the way that I led out this talk, the advantages of the ops platform is that it's providing you abstractions on a lot of this tech. So a lot of it's really complicated, and a lot of what we were starting to understand in DevOps as a whole is that there is a lot of knowledge that needs to be had just to be able to set things up properly and make sure that your infrastructure is going to not only stand up and work, but also continue to run stably. That a lot of the ops platform, we were trying to create those abstractions to reduce the knowledge gap, so that you didn't have to have as much of that background, but you still want to have some basic understanding of some of the pieces and why you would use a Kubernetes versus Fargate versus just running EC2 instances and stuff like that. And so I referenced a couple of ops that we created as open source that work with Kubernetes inside of a blog post, which we can post in the chat as well. But we have an EKS op, which works with the managed Kubernetes service that is provided by Amazon, as well as GKE, which is the managed Kubernetes service for GCP, the Google Cloud platform. So the ops platform will allow you to very simply, by asking you a couple of simple questions, in terms of like what size machine instances you want, and what you want your auto scaling limits to look like. It will set up the initial Kubernetes cluster with the proper nodes set up for you to get off to the races and start running some of your infrastructure. We also had a maintain op that was open source that allows you to connect and interface in a very similar way to the Kubernetes dashboard or using the kubectl, but you're able to do all of that stuff within Slack. And so it'll actually post out some of the states and statuses of your pods and what everything looks like. But it also allows you to get that kind of like group understanding, or you're sharing what the status of your cluster looks like with the team that you're working with in Slack. The only caveat with that maintain op is it needs to work with a Kubernetes cluster that's being set up using the EKS or GKE op, because it has some connections that are necessary there. Yeah, I would highly recommend just to get your feet wet and understand a little bit more about DevOps would be to use the ops platform and one of those ops, the GKE or the EKS, to set up a Kubernetes cluster yourself.
That sounds like a great idea. I think we're all out of questions and all out of time. So thank you so much, Ben, for coming on and giving us a quick overview of DevOps and and K8s, Kubernetes, and also how it can all play together really well with the ops platform. So thank you so much, and hoping to do this again soon.
Yeah, no problem. Thanks for having me.
All right, I'll post a link here to the community at the bottom if anyone wants to come join us and have this conversation every day. And that's it for us. So I'll take us out.